All right, let's get going. We got the review to go over today. All right, it looks like you guys there's a couple main problem types you guys were confused on, so we'll go over that today. Here's what I would say. Be prepared to answer your questions both as a reduced fraction or as a decimal or percent, okay? All three of those, be prepared. So if I say, what's the probability of rolling a 3? Write your answer rounded to the nearest thousandth, okay? We know the probability of rolling a 3 is 1/6. So if I say round to the nearest thousandths, you literally type in 1 divided by 6. You get 0.16 repeating. So 0.167 would be rounded to the nearest thousandth. Okay? If it were to say write it as a percent, then you would move the decimal over twice and get 16.7%. But if I said round, I'm not going to say round your percent to the nearest thousandth. Okay? If you choose to write as a percent, tenths or hundredths are fine. Make sense? All right, so we'll kind of go through those today. I tried to write them a couple different ways for you. If you're going to check one of yours, go ahead and have your calculator out, type it in, and go from there. Here's what I'll say about tomorrow's quiz. If you are not confident on this material, it's going to be really confusing while you're taking the quiz. Not because I'm making it confusing. Listen, I'm not saying I'm doing anything to it that's different than the review. Here's what I will say. If you're a little iffy on some of this stuff, because it's very wordy, what I find is that students get to the quiz sometimes if they're not confident, and they'll be like, oh, I forget. Am I supposed to do this for this one, or is it that for that? Like trying to process, like think of the process while you're on the quiz. That shouldn't really be the issue. You should know, okay, if I read this from the problem, I'm going to do this process, and here's how I'm going to do it. Okay. The only thought should be how many outcomes are there, how many of these are there, and what's the total. Right? Those should be the things going through your mind. Not do I multiply, do I add and subtract, that should be the automatic part. The rules should be the automatic part. The vocabulary should be the automatic part. Okay? So as you go through these, if you're not sure what it's asking, that's an issue. All right? If it's just maybe you miscounted something here or there, that's understandable. All right? So as we go through, please don't be shy. Please ask. All right? But if I say what's the sample space for number 1, that's the list of all possible outcomes. Now, the one on the quiz is not going to have both numbers. Like the numbers in red came from was it like pieces of paper, I think? What was on there? This example was slips of paper with the numbers 1 through 3, and then you're rolling a die. So actually both of those paired together were numbers, right? They could be a combination of letters and numbers, like flipping a coin and rolling a die. You could have a head and a 1, head and a 2, head and a 3, head and 4, all the way up through head and 6, and then tail 1 through 6. So as you list them, think about how you're going to list them in a well thought out, organized way. All right? It'll help you keep track of them. 2 and 3. Any questions on those? Number 4. McKenna.
Do you have to show your work?
Yes. Yeah, because it's like a lot of these are 3 points. And if it's wrong, I'm just going to have to mark it wrong and just take off all 3 points. And right, I mean, I hope you guys have noticed I've been very generous with partial credit all year with quizzes and tests. I try to give, if I can see your thought process. So that's just to protect you.
Like I do it like a different way than that. So my skills should know it like the way I do it, or do you want your way?
Which one?
Like 3 and 4. They're just 3.
So how did you do number 3?
I don't really know, but I got it right. And I got both of them right.
Okay. I mean, math is about the process though, and if you don't get it right, that's the risk.
Yeah.
All right. Questions on 4? All right, help us out. I think some people want to ask a question, just aren't. Why is it we're multiplying a number 4? What is it about that problem that you're like, I should multiply those probabilities? What do you?
It says and, but when you do 6 times 6 times 6, you get 216, and then I think it was 150 seconds. Or is that right?
Well, I reduced my fraction first. So I took 4/6 and I made it 2/3. So just check to make sure we have the final, like my probability 1 out of 54. I'm getting 0.0185. That's possible I typed something in wrong. If you see something you think I typed in wrong, just let me know.
Oh, wait.
Questions so far? All right. Number 5, you pick a heart, do not replace it, and pick another heart. So that first probability was 13 out of 52. But since you picked that heart and didn't put it back, now there's 12 and there's only 51 cards now. Question for you. What if I changed the problem and I said, pick a heart, do not replace it, and then pick a club? What would change in the problem? Who can raise their hand and walk us through that page?
Wouldn't it just be 13 over 51 then? Because you haven't picked any clubs yet.
So first one would still be 13 out of 52 times, and you're saying the second one would be 13 out of 51? Right, because the heart was the first pick. So that second one, where we want to pick a club, and you're right, there's still those 13 clubs, but there's only 51 cards. I wrote it as a fraction. I also wrote it as a percent. Now, obviously, if I said write it as a decimal, just to practice, decimal rounded to the nearest thousandth, 1 out of 17, would be 0.0588. 0.0588. So if I said write it as a decimal rounded to the nearest thousandth, here's the thousandths place. 0.059 would be that answer. Just be able to do it all 3 ways. All right, go ahead and check your answers for 6 through 9. And again, I did look at the quiz while I was making the key. And for the deck of cards problems, it does say there are this many clubs, hearts, spades, diamonds. There are this many, whatever. Callie.
For number 7, if I put 1/4 instead of 13 over 52, it's just reduced, so it'd still be the same.
You'll get the same answer. Yeah. The only time I would not reduce it first is if it's an addition problem where you need to add them, because then your common denominators would be off possibly. So if you reduce the fractions before you multiply, that's fine. Other questions on 6 through 9? Is my work enough for you guys to see if you missed it, what you did wrong? Okay. No other questions? Nancy?
Why do you multiply on 7?
7. You pick a heart, replace it, and then pick a 4. So here's a great example. Here's a great question, by the way. I'm glad you asked this. You always should go back. If you get confused on the quiz, here's a great way to kind of stop yourself, take a deep breath. Some of you kind of get overwhelmed if you're taking a quiz or a test. You kind of freak out a little bit. Here's a great way to just pause and get your mind set back on what you're supposed to do. Do I add or do I multiply, right? Was that the question? Add or multiply. Ready? Here we go. Break it down to the easiest possible probability experiment. What are the chances that I flip 2 heads in a row? Okay, well, what's the probability that I flip a head on the first flip? 1/2. And then on the second flip. Well, we know both of them are 1/2. Do you agree? So then you should ask yourself, if it's flip a head and then flip another head, am I going to add 1/2 and 1/2? Well, that would be 1. That'd be 100% chance. That can't be right, right? It's not 100% chance that I flip a head and then flip another head. It's not addition, it's multiplication. So 1/2 times 1/2 is 1/4. So there's a 1 out of 4 chance that I flip a head and then flip another head. So on the quiz, if you're like, I see and, I do this and then that, do I add or do I multiply? Well, you're going to multiply those outcomes, or probabilities, I should say. Does that help? Other questions through 9? All right, 10 is like a little algebra problem. Some of you left this blank, so look up here. P of A and B is P of A times P of B, because these are independent events, right? We just talked about that. P of A times P of B. Well, I was given the and, I was given the P of A. I need the P of B. I need to divide both sides by 0.45. So I kind of showed it as an algebra process. Divide both sides by 0.45, and that therefore the probability is of B is 0.22. And how could you check your answer? Well, 0.22 times P of A, which is 0.45, should be 0.099. You should get that when you multiply those. Any questions on the front? Please ask if you do. Any questions on the front? All right. This next one I saw a lot of people struggling with. All right, if we're asked the probability of these different areas, isn't the probability that you hit one of these shapes going to be the area of that shape out of the total area, right? Like pretend it's a dartboard, that square outer dartboard. What are the chances I hit the circle? Well, what's the area of the circle out of the total area of the shape, right? The square. And so check your answers first. I wrote them in different colors. So the probability of gray is here, and then black is here, white is there, and black or white is down to the right. Now be careful, the gray area is not that triangle. It's part of the triangle. It's the triangle with the circle taken out of it, right? All right, so here's what I did. If I want to know the probability of the gray region, I said the gray is this triangle minus that circle, and there's the area of it. So the probability that I hit that gray is the area out of the total. So 49.46 out of 256, which is the square. And then what's the probability of the white? Well, the white is that square, take away that triangle, correct? So the white area was 128 square inches. See how to approach this. Go ahead and ask. What kind of questions do you have on that one?
So for the circle, are you putting in 25 like pi I'm subtracting like the triangle from that, like in your calculator.
To get the gray? The triangle minus the circle?
Yeah.
Yeah, so I took the triangle, which had a base of 16 and a height of 16, and then I took away the 25 pi, which was the circle area. Like it's cut out of it, and I'm left with the gray pieces.
But you did put 25 pi and you didn't like solve for the.
Like I didn't type in 25 pi and get a decimal first.
Yeah.
No, I actually typed in, I think, I'll double check it, but the triangle area was 128. I think I just typed in 128. 128 minus 25 pi. Yeah, 49.46 for the gray area. A lot of people struggle on that one. So are we okay, Jackson? Go ahead.
Wouldn't the height of the rectangle or the square be different than the height of the triangle since it's like at an angle?
So yeah, let's go back to what is the height of a triangle, right? So anytime you're finding the area of a triangle, it doesn't matter if it's like an obtuse triangle or what, the height is actually, we call it the altitude height. Like if you're up on that dot and to drop something down, it would be the altitude height, not that slanted side length, right? Thanks for asking that. So did you do a little Pythagorean theorem here? Okay. Questions on that? All right. Now for the two-way table. Check your total first. Make sure you got 122 for those.
I'm confused on what total is. Like I mess up. Like I use like I don't understand when it's like asking the entire thing or just like one thing, or if you add together with J's, all the J's,
So
I used to when it says like the girl names, I always use them. No,
Because I had
okay, so we got some questions about totals here, all right? All right, we got some questions about the totals here. Let's pretend that all of these entries have one slip of paper, okay? One person, since I can tell some of us are having trouble focusing. What goes on the slip of paper for this experiment? What goes on each slip of paper? So on a piece of paper, it's going to have either male or female, right? And then what? The name. So maybe Joey, Ross, Rachel, Chandler, Monica, Phoebe. All right. So yeah, Mrs. Wolf likes Friends, so she made this one. So each one, let's say it has an F and a P. You pick out a piece of paper, and it has an F and a P on it. How many of those are there? 12. Here's what I do. F. Okay, F, P. There's 12 that have both an F and a P on them, correct? So here's what I did, and this is where some of your questions are coming into play. If there's 55 males and 67 females, okay, then if I were to take out the pieces of paper, ignore the names on it, just count off the F's and the M's, females and males. How many slips of paper are there total? 122, because there's 55 females and 67 males. There's 122 slips of paper. Do you agree? The other way you can find that is to ignore the female male and just to count the names. There's 19 Joeys, there's 17 Rosses, there's 19 Rachels, there's 33 Chandlers, there's 10 Monicas, and there's 24 Phoebes. Those should also add up to 122. Some of you are adding them twice. No. There's slips of paper have both female and male and the names on them. You shouldn't add up those twice. right? The totals come from either the sum of the rows or the sum of the columns. They should match. The sum of the rows and the sum of the columns should match. They're both 122. Tally.
How do you read number 17 and 18? Because I mixed up the
We'll get to that in 1 second. I definitely want to address that. I just want to make sure we're okay with the totals first. Paige, are you okay with the totals?
Oh, yeah.
Okay, let's address the totals right now. I still have questions on those. Do you guys understand what I'm talking about when it comes to the totals? Anthony, makes sense?
Yeah.
Liv? All right. Tally. 17 and 18. Okay. Do you know how to read this, number 17?
No, that's why I asked.
Okay. P of M given J. Okay. So what's the probability of picking a male given that it's a Joey?
Yeah, so I read it backwards.
So, given that it's a Joey, I should look at the Joey column first. Good news, Tally. As soon as you isolate that column, that tells you your denominator for your probability. Okay. So P of M given J, well, how many J's are there? 19. So then I look, what's the probability of picking a male out of the Joey column? Well, that's 11 out of the 19 Joes. Okay?
So do you do the second letter before the first letter?
Yes. And guys, one more thing.
And that's how you put it in the fraction, like the numerator?
It tells you what to isolate first. Ready? And you did great with this when I did the die and the coin. Ready? I know you're going to get tired of this, but this is what your mind should go to if you're stuck on a quiz. Okay? What's the probability of rolling a 3 given that I've already flipped ahead? Which one happens first? The coin or the die? The coin happens first. So what's the probability of rolling a 3 given that I've already flipped ahead? Okay, so how about this one? What's the probability of M given that it's in the J row? Do you guys see how you look at the J row? Sorry, the J column first. Yes? It's that second letter that you isolate first. Makes sense? So let's do the next one. P of J given M. Everybody look at 18. P of J given M. I'm going to do this one in red. Given that it's in the M row, okay, so I isolate the M row. That tells me my denominator right away. Right away, I'm writing down 67 as my denominator. Given that it's in the M row, what's the probability of picking a J? Oh, well, how many J's are there? Well, 11. Coincidence. That was a coincidence that it was 11 this time too. I could have said, what's P of C given M? Okay. So 11 out of 67. Let's actually do that. P of C given M. Well, good news. We've already isolated the M row, correct? P of C given M. Given that it's in the M row, so right away my denominator is 67. Then you should ask yourself, what's the probability of picking a C out of those 67? How many C's are there? In that row, there's 18 C's, right? 18 out of 67.
Bro, why do you use 19 for 17 instead of 67?
Because it was given that it's in the J column. There's 19 in the J column. Okay? So listen, conditional probability. You narrow it down first. Here's the visual on this, okay? Everybody can picture this hat with all these slips of paper in it, right? How many slips of paper? 122. But guess what? As soon as you do conditional probability, I need everyone to listen. As soon as you do conditional probability, there's no longer 122 slips of paper. Here's what happens. If I say what's P of C given M, what's the probability of picking a C given that it's an M? What's the only thing left in the hat? Slips of paper that have what on them? I want to know what's the probability of picking a C given that it's an M. What is in the hat? All the M's. There's 67 slips of paper. Let me say it again. What's P of C given M? Well, given that it has an M on it, males, what's the probability of picking a C out of all the males? Well, guess what's in the hat? All the males. The 67, right? Given that it has an M on it. So everything else is taken out of the hat. Did I say something wrong? I'm sorry. This is kind of tough to explain. All right? Everything else is taken out of the hat. Except for those 67 M's. So guess what? Aren't the chances better of picking a C now? What's P of C given M? Well, there's 18 C's out of the 67 M's. Does that make sense? This is like a foreign language to some. I get it.
For 17 and 18, they switch which one is like for 17, the second one is on the bottom.
Yes.
The second one is on the top. For 18, the second one is on the bottom.
Yes. Because it narrows it down first. It narrows it down to a column or a row first.
No, I think that's it.
Page.
Out of all the
15 and 16, I got really good at that.
Hey guys, quiet please. Shh. All right, Paige. I'm going to eliminate these right here, so our eyes aren't confused. All right, so Paige, let's start off with the basics. You said 15 and 16. What's this symbol? And. So let's look at where the slips of paper are an M and an L. How many slips of paper have an M and an L on them? M, L, ready? M's, L's. How many of them have both an M and an L? 14 out of the total of 122.
So you don't do any multiplying on these ones?
No, it has to have both an M and an L. Ready? Remember my example. You're on market and 619. Ready? Market 619. There's the intersection. It means both. And means both. There's another question. 16? All right, so Paige, for 16, are there any that have a J and an R on them? No, there's zero chance that you can pick a slip of paper that has a J on it and an R on it. Either have a J or an R on it, right? Not both. All right, scrolling down. I did not reduce that last one. Actually, I didn't reduce a lot of these. These ones, by the way, these ones on the quiz are going to be asked. You're going to be asked around to the nearest thousand. These are the ones you're going to be asked at around to the nearest thousand. So like 16 out of 122, or sorry, 66. 66 out of 122. 0.541 would be your answer. 0.541. Questions on these? So here are the options, okay? I'd be happy to, if you're too nervous to ask in front of the class or didn't want to, whatever, or still want some time to look at this, I'm going to post the recording. I've also posted a practice Kahoot on it's only on geometric probability. So the ones where you had to find the areas of the shapes and divide by the total. If you want more practice with that, okay, there's a Kahoot. It's self-guided. You can click on it. You can practice that right now for the rest of the class. That's fine. They're just extra problems. All right. I would definitely review. Okay, practice problems similar to these. Make sure you're not still asking yourself, do I add, do I multiply? Like, that kind of needs to be automatic at this point, okay? So we'll stop there. If you have individual questions that you'd like to ask, feel free to. Otherwise, we'll kind of have independent study time.